Thanks for joining. We are inside day number 3 and we are going to learn about Cisco SD-WAN bring up process. Bring up means that how the control plane bring up happens, how the data plane bring up happens, the key components that we have in the control plane and data plane, how they will go and join the fabric, what are the protocols which is going on or running in between these components, what are the security measures we have, everything we are going to discuss today. Now, before starting that, I just wanted to draw the diagram that we have done yesterday, that we are discussing about the control plane connections that we have in between within the controllers and in between the control plane and the data plane. So suppose if we have vManage, vSmart, vBond, and then if we have the edge devices, say vEdge devices, vEdge1, vEdge or CH, vEdge2. So these devices, how they are connecting and what are the protocols running. So yesterday I draw the diagram like the control connections that we have is either DTLS or TLS. I'll not draw everything. We have in between, we have ISP as well, some service provider network and all. So we know that in between that we have this DTLS or TLS, and in between device to device, we have nothing but the IPsec. I want to add one more thing here, and in future we are going to learn about that. Where you know that we have vSmart, right? And vSmart is working as a control plane. This is the intelligence behind the fabric, all the routing decisions and IPsec key exchange and other things, they are happening, or the vSmart is responsible for that. So if I go and list the high points that vSmart is doing, it will go and create all type of routing changes and traffic engineering and routing policies and control things. So control policy is nothing but the routing policy behind the scene. So vSmart is doing that. Now, if two devices, they have to go and form the IPsec connection, what is happening that you know that the edge devices to edge devices, we have connection or we have the communication with help of vSmart. So what is happening? Suppose if vEdge1 and vEdge2, they want to form IPsec tunnel in between them. So vEdge1 should know the key, the private and public key that we have. So the key, he should know the key. Suppose this is key number 2, this is key number 1. So he should know the key number 2, and vEdge2 should know the key number 1 in very simple form, but there are so many things that is happening behind the scene. So what is happening here is this, that the edge devices, they are sending their key to the vSmart. So key 1 and key 2. vSmart knows the key 1 and key 2, and then vSmart is responsible to exchange the key in between the edge devices. So the vSmart, they are termed as a key server as well. KS, key server. They are managing the key for the entire fabric for all the data plane devices. Okay, and finally what vSmart will do, from vSmart you can go and create the policy. Actually, you can create the policy at the level of vManage. vManage will push the policy to vSmart, and then vSmart will go and push the policy to vEdge. So these three things at least that vSmart is doing: routing, key exchange, and policy exchange. Now, why I draw this diagram? Just to make sure. So at the moment you may think that I'll draw here so it will be clear. So at the moment from that diagram, I haven't erased this diagram. This is also true. So at the moment you think that, okay, vManage will go and push. So in vmanage we have option, we can go and create the policy, because policy and templates you can create from vmanage. So from vmanage you can go and create the policy, and that policy will go and push to vSmart, and then vSmart they will go and push that policy to vEdge, right? In a diagram it's very simple. Now here you may think that, oh, since they have control connection, either DTLS or TLS. I'll write DTLS here. So at the moment you may think that, oh, the policy that we manage is pushing to vSmart, it will go and use some sort of DTLS connection in between them. Via the DTLS tunnel it will go and push the policy. Likewise you may think that, okay, vSmart and vS devices, they have some sort of control connection DTLS, and with help of DTLS they can go and push the policy, right? But it is not true. The policy that it will push from here to here, policy configuration, that will happen with the netconf protocol, network configuration, netconf, right? And then the policy that vSmart will go and push, not only policy or key exchange or any type of routing. So they will go and use some sort of OMP, overlay management protocol, OMP. We have complete 1 day or 2 day session just related to understand OMP, so don't worry about that. But the protocol that is running in between vSmart and vEdge is nothing but overlay management protocol. So if I go back to the diagram here, and suppose if we have two vEdge device, and I'll go and use some other color, maybe let me go and use some blue color. So from vSmart to vEdge we have something called one protocol, that is OMP is running. Now it's a characteristic of OMP. Sometimes it is referred as a lightweight BGP. This is the overlay protocol we have, overlay management protocol we have, and the characteristic of OMP. Within the OMP, all these things are happening: control exchange, key exchange, and policy exchange. Now the VS devices, they are OMP peer. So if I go and check show OMP peer within the vSmart, so it will show you that VH1 and VH2. VH1 and VH2 is my OMP peer. And now it's like EIGRP or OSPF or BGP. Like in EIGRP, you can run show IP, EIGRP neighbors. OSPF, you can run show IP, OSPF neighbors, etc. Like that, you can go and run the command show OMP peer. It's a protocol. So it will tell you that this is the peer and this is the peer. And if you go and check show MP, peer in detail, etc. So in that output, it will show you about the routing, key exchange policy, etc. Those informations in detail. Okay. So there is one small catch that we should understand. The catch is this, that VH1 and VH2, they are not OMP peers. The OMP peer that is forming is always forming in between edge devices and the vSmart. The two edge devices, they are not forming the OMP peer within themselves. In that case, you can think that vSmart is working as a route reflector. You know the concept of route reflector? If we have BGP internal peering going on within same autonomous system, so if you are running iBGP, so in that case, you can't protect from the internal loops or routing loops, because whatever neighbor will learn, it will advertise to other neighbor and all. So in that case, to overcome from that routing loop within the autonomous system, we are creating some sort of route reflection, that he is the parent, he only knows the route and he can advertise like that. So the concept here that we have related to vSmart and vEdge, it's not new concept. It has somehow taken from the route reflection concept. And if I have any slide, okay, I don't have any. Okay, so I'll go and clean this slide, and then I want to draw something. So you'll understand more. Is it okay? Shall I clean this? Okay, I'll go and erase it. So what I want to draw here is this, that if you have vSmart and VS devices, so they will go and form. Obviously, they have control connection DTLS, but the protocol is OMP. And suppose if we have two vSmart, then the protocol is OMP. You know, this is behind the scene. This architecture behind the scene, it is referred as a clause fabric architecture. In ACI, if you learn ACI, you'll find that if you have a spine and leaf, suppose spine 1 and 2, and then you have leaf 1, leaf 2, leaf 3. So as per the clause architecture, all the leaves, they are connecting only to the spine. There is no concept of doing connection in between leaf to leaf. And here also you will see that similarity, that there is no OMP peering in between VH to VH. So now if VH devices, they have to go and form the IPsec tunnel, they will send the key to vSmart, and vSmart, since it is working as a route reflector, it will go and reflect the key information, the routing information, everything to the other device, and vice versa. Again, it will go and send the key, and then the vSmart will send the key here, and vSmart will send the key here, and then they will go and form the IPsec tunnel in between the data plane. Okay, so knowing this fact, this is going to help us to understand the bring up process. So let's understand the bring up process. Now, if I go and list out the bring up process, but I will go there. If you have any question, any doubt, you can ask. Then I can go to the bring up process. Correct, right? So let's think about the bring up process. Let's understand. Bring up process. Two phases are there. We want to bring up the control plane, and then we want to bring up the data plane. Right? So let's zoom inside the control plane. Let's understand the control plane bring up. Now inside the control plane, what are the things we have? So we have vManage, we have vSmart, we have vBond, right? So we know this fact that the vManage, they need at least two NIC. If you have multiple vManage, you need at least two NIC. One is for VPN 0, one is for VPN 512, that's the management. So one transport VPN, one management VPN. Likewise, you need for vSmart, vBond. But for vManage, you need extra storage, at least 50 GB, if you want to deploy this in your lab or maybe in POC environment. And that's the one thing. So what is the prerequisite? If I write here, the prerequisite is this, that you should have some hypervisor. And on top of that hypervisor, you can go and install the image, right? And obviously these things we'll see in our lab in upcoming days. I will show you all these steps. So I need one hypervisor, and I want to install this operating system on that. Now once I install this operating system, then you will see by default it will show you 2 or 3 interfaces. That means we can go and map the internal VNIC to the external interfaces and all. So that means that you have to go and define the VPN 0, VPN 512 in a way that all controllers should reach each other, right? So if you have to go and put some sort of a static route pointing towards the next hop, or maybe if these devices, they have some sort of shared LAN in the lab environment, we have LAN device, means they have some common network behind the scene, so they can reach to each other. Okay, so the step one is that you need the hypervisors, you need to install the OS, you need to define VPN 0, VPN 512 IP addresses and all, and you have to go and do the basic IP routing configurations. Okay, and then finally you have to go and install the certificate. So this is some install. Here you have to do the configuration, and then you have to install the certificate. All these things I will show you. Now in these 3 steps, if you have any doubt, please ask. Means just to know the steps, 3 or 4 steps. Clear, right? When we'll do the lab, we'll obviously understand the details of this. Okay. So we have vManage, we have vSmart, and we have vBond. Okay. So what we have done, we have defined the VPN 0. These are the WAN facing interfaces, and VPN 512 everywhere, 0 and 512, 0 and 512. 512 is nothing but out of band management IP, where you can go and out of band management. These are the VPN 0, 0, 0, etc. And this is nothing but your VPN 0, VPN 0, VPN 0. So VPN or VRF, both are the same thing, right? So now that means that you have to go inside the VPN 0 and you have to do the configuration. So if you go and break down the configuration, you will find that you have something called global configuration, and then you have some specific configuration. So global configuration means that it will be global, and we have actually some mandatory global configuration. Mandatory global configuration means some 4 or 5 lines of that configuration you have to put in all the devices, either it's a control device or it's a data plane device. Okay, so these mandatory device configuration that we have, you have to go and define the host name. What's the host name? Host name. Then you have to go and define the vBond IP. Remember, all the devices in a fabric, either it's a data plane or control plane, they should know the vBond IP. They should reach the vBond, and vBond having some sort of whitelist. We'll check that. So he has some sort of list from where he will go and check, oh, this is coming for validity, I can validate. So to get that validity, obviously all the devices should have the reachable vBond IP or DNS, etc. Right? Then third thing, some sort of site ID. We'll go and learn about site. It's a new thing which was not there in the Cisco devices earlier. So all devices should belong to some site. They should have some site ID. And then they should have some sort of organization name. This is part of some sort of certificate. Okay, so what are the important things we have? We should have the host name, vBond IP, site ID, organization name, and the last thing is the system IP. It's not clear. Again, I'll go and write all those things. So let me go and write. So what I'm telling, suppose if we are inside the vManage, it should have some global mandatory configuration. It should have these 5 very important configuration. Should have the host name. It should have the system IP. It should have the site ID. It should have the reachable vBond IP. Should know the vBond IP. and it should have the organization name, because this is something that will be coming into the picture when we'll go and install the certificate. So host name is just no brainer. It's the name of the host, and this is going to be used for the certification process. V1
I
IP
have,
unit. Mhm.
I have a question. So is the system IP similar to like a router ID and OSPF like that? Or is it something different?
I'll come to that. Yeah, it's
Oh,
same.
got it.
I should have reachable vbond IP. And then site ID is very interesting, and later on you'll understand more and more about site ID, but it's type of grouping the same type of devices in same site. So suppose I have one site whose ID is 11, and then if I have three devices in that particular site ID belonging to 11, that means both are part of one group site ID, that is 11, and by default, if these devices in the same location, they will not form the IPsec tunnel in between them. Now suppose if we have site ID 12 and one device is there, then site ID 12 can go and form the IPsec tunnel with all the site ID 11 devices. So the default nature is this, that devices belonging to same site ID, they are not forming the IPsec tunnel in between them. Okay, that's the significance of site ID. Now coming back to the system IP, because that is a big thing. System IP. So as Richard mentioned, that it's very much like the router IDs in BGP or OSPF that we are giving. Yeah, that's true, but system IP is a type of IP which is not routable or routable. It's not part of routing table, etc. So why we are putting system IP in a device? We know this thing, that once we are putting system IP, it's like very much like loopback 0 IP. It's a logical IP on that particular device, or maybe if you work on F5 load balancers, you know that we are putting some sort of system IP in the load balancers. So suppose in your device, if we have three physical interfaces, just for example, gig 1, gig 2, gig 3, if all these physical interfaces will also go down, is still your system IP will not go down. Still the other system will recognize that, okay, it has one logical system IP, and I know this device with the logical IP because it's not a physical IP. So as long as the system IP is there, that means that device will be recognizable to the vSmart and all. Other use of system IP later on you will understand when we'll go and study about transport locators. The transport locator, although it's a big thing, but it has three main component: system ID, site ID, I think, and the color. We'll see system ID, site ID, system IP, site ID, and color. The transport locator is a very interesting thing. We'll learn later on, like OMP and TLOC. There are some sort of new things that we have to learn in the SD-WAN. So don't worry about that, but system IP will be part of TLOC, transport locators. We have dedicated slides for that. We'll understand more about that. All right. So before I move further, I have two questions to everyone. Question number one, tell me the top three features of vSmart or OMP. Top three use. Yeah, you can answer.
Let me say it again.
Yeah, top three use of vSmart or OMP. What vSmart is doing is usability.
Um,
I mentioned earlier that it will do
Policy,
policy, right? Routing policy
certificate.
and it will work as a
Oh,
key server. Yeah,
yeah.
Oh,
reflecting.
e-server. Sorry.
they're working as a route reflector. That's right. But it will do routing, central control policy we are creating from OMP or from vSmart, routing policy and key server. These three things, and then bring up process. So bring up process. Can you tell me the bring up process? What are the steps? Install the OS. Then configure. In configuration, you have two things: global configuration, and then you have to configure VPN 0,
Mhm.
a VPN 512, and then you have to create IP route in between the controllers. Right? Inside global, what are the 5 main components you have to create? The configuration you have to do.
Okay.
To all the devices you have to do. You have to give host name, system IP, right?
Mhm.
Site ID, SIP and SID, system IP and SID, site ID. And then you have to give the reachable vBond IP. And then finally, you have to give the organization name, org name. These 5 things you have to give: host name, system IP, site ID, vBond, organization name. And final step is to do the certification. Once you do, then your control plane will come into the picture. Right? Now, the next thing is this, that you have to go and bring up the data plane, and data plane also you have to do the same thing, because it is not a software. In case if you have a software form factor for the data plane devices, then you have to do all these things. Otherwise, you have to do a step number 2, a step number 3. Right? So knowing this thing, let me show you everything in the slide. So here you have the slide. Install the hypervisor, spin up the virtual machine. Let me clean this. All right. So install the, I can see the hypervisor, spin up the virtual machine, install the images we want vSmart, right? Then create the minimum configuration for vManage, then for vBond, for vSmart, then do the routing in between them. The step number 7 is the routing. Then generate the CSRs, sign the certificate. Now you can see that the steps that we have discussed, that do the spin up of the devices. So from step number 1 to 3, then 4, 5, 6, 7 is something like configuration and IP routing, and 8 and 9, they are the certificate things, right? Then the configuration and then the certificate. So install, then basic configuration, and then finally the certification you have to do. Likewise, for VAs also you have to do almost the same steps, but the steps are limited in VH, that limited steps related to certification. So the point here, I'm going to give you one very important point. Just after 30 minutes of the recording, you can watch. So the point here is this, that since, okay, I'll ask you another word. So the number of controllers are always less than the number of edge devices. Number of edge devices may be 1000, number of controller may be 10, right? So the point here is this, that for the controllers, you can do some sort of manual certification process. Manually, you can install the certificates and do this, generate the CSRs and all those things. But for the edge devices, if you do all this manual thing, then it will take too much time. So that's why the certification process that we have for edge devices, they are very much automated in the Viptela fabric. So we have automated certification process for the edge devices, because for 1,000, 2,000 devices, you will not do all the manual things. Now we know that Cisco is recommending their customer that you use the cloud hosted controllers. So that means that your control plane will be up and running. If you go and take the control plane from the Cisco, the next thing that you have to do is to bring up your edge devices. And since the edge devices bring up process is automated, that means that if you see the steps here, you have physical device, right? So don't need to do these hypervisors and blah blah all these things. What you need to do, you have to go and configure VPN 0, VPN 512. Okay, and one or two line of certificate things. So your device should know the reachability. Even if they don't have anything related to certificate, doesn't matter. If you have proper vBond IP, it will go and get certified from the cloud. So that means the overall bring up process for the fabric, for the control plane and data plane is actually very easy in the corporate, in the organization. Okay, great. So these are the steps in the lab. I will go and explain all these steps in upcoming days. You will understand more and more. The only thing you have to take care about the bring up process is the certification things. Apart from certification things, each and everything is very easy. All right, great, good job. So let's move on. So now you can see that once you do the bring up process for the controllers and the edge devices, there are some steps. You can see these steps are happening behind the scene. I will go and explain everything later on. For data plane, you have these steps that is happening. These steps that is happening. I will go and read everything. I'll explain everything. Behind the scene, these steps are actually SSL based authentication. I can see how the TLS or DTLS is forming. Behind the scene, actually, this is SSL, certificate based authentication, and the mutual redistribution of the certificates and all. It's explained in these 4 slides. I will explain these 4 slides in the next class. Now, once your data plane is up and your control plane is up, you can go and check some configuration. Obviously, I'll show you this configuration. So control connections, so certificate installed and all, right? And that's it. Now we are ready to do any type of configuration, BGP configuration, routing configuration. And now we are ready to play around with the local policy and global policy, and app aware routing and all those nice features that we have in the SD-WAN. But still, this is not the perfect SD-WAN, unfortunately, because SD-WAN should do much more than whatever is happening here, and the steps should much more optimize that whatever we have here in Cisco SD-WAN. So obviously they are working on improving in this, but the framework itself has some, what you can say, some lacking in intelligence. The framework itself is not that much intelligent, so whatever features they will put, they will come after the framework. Okay. So there are some problem as well with the Cisco SD-WAN. Problem in terms of that it's not very intelligent SD-WAN. Like it's SD-WAN, but it's not like so many competitors are there in the market. It will not solve all the problems in the WAN, maybe 30 35%. That is not good. As a true SD-WAN, there should be much more optimization that we are seeing at the moment in Cisco SD-WAN. It should do more than this. Okay. So my task is this, that I have to go and show you everything in the lab. But before going there, let me see if I have something to show you. Yeah. So I have this bring up process and how to build your lab. thing as a notes. I will go and explain you this notes, and I'll share with you as well. Although this has been taken from this site, coding packets. I will ping you the URL. Someone has written nice blog. I just copy this blog for the class purpose. Codingpackets.com blog. They they have shown that how you can go and bring up in a legacy term like images, older images like 16 before 16.x. You can say 16. Now we are in the 20. So the lab I have shared with you, those are 20 dot something. They have so many features. Actually, this was Viptela. Now we have Cisco SD-WAN. So if you are using this older images, so you can easily build your own lab, home lab, etc. If you are using some new images, then that process is little bit different. And you need certificates, sign certificates, some sort of things from the Cisco. Okay, but for learning process, obviously we'll understand both the things, but to build your lab, this particular document is enough. I will go and follow this document. I'll show you in the lab. So far, if you have any question, please feel free to ask. If no question, then I will go and quickly go through this particular setup that we have. Okay, so what you will do, you need hypervisor. You want to install the image on that hypervisor. You will do that. I will show you that in the upcoming sessions. Then you need some sort of minimum configuration, right? So minimum configuration you need, that means you need basic configuration, 5 mandatory minimum configuration, host names, SIP and SID, organization name, and the reachable vBond IP. So you can see here in this that you have the system IP, you have the site ID, you have the organization name, you have the vBond, etc., etc. Then you need this VPN 0 configuration, you need this VPN 512 configuration. This is the minimum. You can think this as a bootstrap configuration. This is the minimum configuration you have for vBond, for vSmart, for vEdge also minimum configuration. Then you have the complete certification process. The certification process that you are seeing here, better I will show you in the lab so you will understand more, right? So you bring up that particular vManage, and then you can log in that vManage via the GUI. Once you open the GUI, you will go and add the organization name, the vBond IP. So adding the organization name and vBond IP, and then do the basic configuration, and then it is showing you that vManage you can use as a server to generate the key and share the key. So vManage is working as a root server from where we are generating the key and then sharing to all the devices. I will show you all these manual steps. Once you go, you have to go and generate the CSRs. The CSR, from this CSR, we have to go and generate some sort of PIM key, permanent key, or the certificates. And then we have to go and install the certificate. Once you do these steps for vManage, vSmart, and vBond, you will see that your control plane will be up and running and in the fabric. So once everything is done, then you will see that within the vManage dashboard, it will show you that you have all those devices installed, and it will show you 3 controllers up and running. Okay, now next turn is to add the VS devices. We'll go and follow the certificate process because we have already put the basic configuration for the S devices. Just follow the configuration, and then by the end of this process, you'll find now your S devices is also part of that. You can see the control connection, you can see the certificate install, and in the dashboard, finally you will see that if I have the dashboard here, let me quickly go and show that. So in the dashboard, you will see this page. So vSmart is up. So you will see that you have vSmart up. You have VH, suppose one VH you are making up. So one VH up, vBond is up and running, and the vManage up and running. Somewhere in the configuration and certificates, you will see that all certificates are installed properly and working properly. So that's the end goal we have to reach. Once we have this control and data plane up and running, then we can go and use all the other services like VPN1, VPN2, VPN3, etc., etc. Long list of services we can go and add. This thing I'm going to show you in the lab, so don't worry. This you will understand this. Okay. So I will do the lab not now. We will do in upcoming 4th or 5th session. But before reaching to the lab, I'll make sure that you understand these basic things. And then if you just follow this slide, you'll find that I have one dedicated a list of slides just to understand the vManage dashboard. So you have to go and log into the vManage and you have to check different things inside the vManage. And then here you can see, I told you that we have something called global configuration. So we have this system-wide configuration where we can go give host name, GPS, clock, time, AAA, very much Cisco type. TACACS, OMP is new thing we have to learn. And then you can see this bold system IP, site ID, host name, and vBond, and organization name and vBond, and this host name is also. So there are 5 mandatory configuration that we should put. And then we have something called the VPN 0 configuration. We have service VPN configuration. Service VPN is starting from 1 to 511. And then you have VPN 512 configuration, and then you have the local policy that is local to the box. And there is something called global policy as well. Global policy, from where it will come? It will come from vSmart. Later on, we will understand that. Okay, so likewise, we have to follow our slides. They are built like this, so you will understand slowly each and everything. So in the device, what you have to do, system IP, site ID, organization, vBond, and host name. You have to configure this VPN 0. You have to configure some VPN 512 if you have some OOB IPs, etc. And then once you do this, then your bring up process will kick on. So everything is there in the slide. I have made this slide like this, how to configure in the devices. Anyways, I will show you that. I log in and I will commit, we will commit these configurations. Later on, we'll understand. Then what configuration is doing what. Just for your reference, these are the reference slides. Later on, when we'll go VPN, when we'll configure VPN 0 and other VPNs, so you will understand more and more about this. This configuration hierarchy look like this. Inside VPN 0, you have these many things. Again, you'll understand in upcoming session. So what is my strategy? My strategy is this, that the bring up process we will do, but we will do not now. I will do this lab maybe after 4 days. But before this bring up lab, I want to make sure that you know how SD-WAN look like, how the basic things look like, how to do basic things, basic configuration, etc. Then I will go and bring up the lab. Even you can do that lab in your laptop as well. I'll share all these old images as well, so you can play around with those old images and all. Okay. All right. If you have any question, please feel free to ask.